And today we get to dive a little bit further into NASA's Double Asteroid Redirection Test, also known as DART. You probably heard of the mission. It's all over what people are talking about in terms of space. And there's a lot that it was meant to do. There's a lot that out there that it wasn't meant to do. And I thought, let's go to the source. Let's go to our friend Bill, he's the lead NASA Meteoroid Environments Office there in Alabama, close to us here in Mississippi, to give us the details. So, hey, Bill.
Hey.
It's so good to have you back and talking space. This was a pretty historic moment for all us space nerds, right?
Yeah, normally we try to avoid running into things up there, but this time we decided we were going to smack something into a rock and see what happens.
I absolutely love it. It sounds like so many Mississippi kids on a summer afternoon. Like, let's just throw this and see what ends up happening at the end. So what was the point behind it? Why did we want to test and see what would happen if we plowed into this big object?
Well, you know, most people, when they think of asteroids hitting the Earth, they think of the big dinosaur killer, right? 65 million years ago. Or they think about Deep Impact or Armageddon or the Greenland movies, right? But, you know, what an average person is likely to encounter their lifetime are not the big rocks of doom that are going to end civilization. They're going to be smaller asteroids that have, you know, a megaton to 10 megatons of energies that can take out a city, but, you know, not destroy the planet. And these smaller rocks come in about once every 50 to 75 years. So, you know, there was one in 2013 over Russia that was half a megaton. And then back in 1908, there was the Tunguska event, which was 10 megatons. So if you look at things from the perspective of what do I have to worry about in my lifetime, it's these smaller rocks, these city killers. And DART enables us to test technology that we would use to deflect these smaller asteroids. So for a small asteroid, you don't have to pull a nuke out and, you know, get Bruce Willis out there with drilling equipment. For a smaller one, you can hit it with a brick or a big spacecraft and deflect it away. And DART helps us test this technology. We call it a kinetic impactor. And when DART approached the asteroid, that spacecraft, which weighed a little over 1,100 pounds, hit that moon of that asteroid, moving at a speed of 4 miles per second. So in terms of energy, that was equivalent to 3 tons of dynamite hitting that asteroid. And it created a bit of a mess. We could see the debris through telescopes here at Earth. And, of course, there was this little Italian CubeSat that flew by and took pictures afterwards.
The math required for that makes my head hurt, Bill. Like the idea, and I think that's another thing that people are missing is just what a feat this was to actually hit it, right? Like the fact that we were precise, well, we, as in me, I was in there, I pushed the button. But like in terms of NASA, was able to actually accomplish this task is a big deal.
It is a triumph for NASA. Again, hitting a small asteroid is not easy, but we got computers nowadays that enable us to, we can basically, if you watched it, you saw in the last couple of minutes, they just let the computers guide the spacecraft and smack into the asteroid. And it wasn't like the early days of NASA when we launched up and, towards the moon and we would miss the moon, So we're doing a lot better now than we used to, that's for sure.
Well, I think it's super cool. And I think, too, there's a lot of talk about, does this mess up any kind of rotation or all the force fields or whatever up there? I mean, this is like a safe experiment, right, in terms of for us here on Earth?
Yeah, so we picked Didymos, which is the name of the asteroid, and its moon Dimorphos, for a reason. One, it isn't projected to hit the Earth for millions of years, so we can mess around with it and not worry about it, coming back to haunt us like, oh crap, it's suddenly heading towards us. So we could do experiments without endangering the Earth. And the other reason is if we hit the moon, as the moon goes around that asteroid, it blocks out part of the reflected light from the asteroid, so we can measure the time it takes to go around the asteroid very precisely. So after the impact changed the orbit of the moon, so that timing will change. So all we got to do is watch that asteroid and look at when it dims, and by noting the change in time before we hit it and after we hit it, we can estimate how well we did in deflecting it. So it's kind of pretty cool. That was the reason we chose this system.
What I love about any time NASA does something they're proud of, it's just the excitement and the celebration in the little cockpit or whatever room, the control center. It's like when they land or they take off successfully or they, something cool happens. It took, a ton of people working together at their highest, level to make it happen. And then they all rejoice. And I'm like, yes, like right there with them, like, woohoo. It feels like you're part of the team.
Yeah, and, as I was watching it, I was sitting there thinking, well, this is ironic. If this had been any other mission, we would all be crying now because we smacked into something. But, there was a lot of celebration and stuff, and rightly so. They accomplished a great deal there in doing DART. So we'll see how well these kinetic impactors, how well smacking things into a small asteroid will deflect them. So we're testing out a way of saving cities here.
I love that. One thing I enjoy about space, Bill, is just this idea that it makes you realize how small and insignificant you and your life and your country and your problems and your political divide and all of that really is when you think about all the expansiveness that is of space and what the Creator all created and the fact that it could all end in an asteroid, right? Or something sort of similar. And I find, it's crazy it sounds, Bill, I find great peace in that, knowing that there is still something so much greater than, us here and our little squabbles, and that there's people out there watching it, hopefully making sure we are deflected in that. I mean, I don't really want an asteroid to come to Earth, but you know what I mean.
Yeah, that would not be a good day, right?
No, it would not be a good day. I bet your phone would be ringing off the hook, and I wouldn't be able to get you on good things.
No. I would just refer them to the Planetary Defense Officer at headquarters.
Well, Bill, I appreciate your time here walking us through it. It's always a pleasure. And, I think it's super cool, and people should at least be aware of the historic event that happened with DART.
Well, thank you for having me. I appreciate it.
How cool is that? And, that's not necessarily tied directly to the work there at Stennis Space Center, but yet in a way that it is. And I think sometimes we can get all wrapped up in the headlines and what they say and what it is or what it isn't. I actually heard you and Gerard talking about it for a brief moment today on Middays, Rhino, and you were poking fun at the way the media sort of spun the mission. But, again, it just brings me great joy to realize that there are things so much greater than us and our little problems here, particularly here in the West and in America, that you're just reminded that there are still real big rocks out there that could just come and take us all out in a minute. And, it reminds you that, life's too important to take everything so serious.